Okay, so in this lecture, I'm going to be talking to you about the scientific method. The scientific method is, as is seen on the slide, is a set of steps or procedures that researchers use to understand and explain behavior, cause and effect relationships, or other events in the world around us. It starts with a prediction, so oftentimes we make predictions about how certain events are going to produce specific outcomes. So, for example, I might make a prediction about how a particular personality trait might influence a person's tendency to become addicted to drugs. It can involve control. So, I might be able to control people's exposures to different contexts and see how varying the context is going to affect the outcome. For example, I can say control whether a person drinks alcohol or water, and I can see how that then affects their risk-taking behavior in a controlled setting. And then finally, it involves theory building and testing. And so a theory is an explanation for a set of observations or events. An example would be the theory of operant conditioning, which you should have learned about in introductory psychology. And as an example of that, so that theory is that the strongest influence on a behavior is its consequences. And that theory actually can generate testable hypotheses, right? So these are predictions, right? I can predict that if that is true, then if I reward a certain behavior, like if I reward you turning your cameras on by giving you extra credit for doing so, that will increase the likelihood that you're going to turn your cameras on, as an example. Okay, so first let's talk about the principles of the scientific method. The scientific method is deterministic, or is based in determinism. And this is the idea that events have meaningful causes, that the world or the universe is kind of an orderly place, that events have meaningful causes, and those causes can be identified using the proper methodology. The second is empiricism, and this is the idea that there's a bunch of different ways in which we can know the truth, but the best way to do so is through observation. And when I talk about observation, I'm not just talking about what we can see with our eyes, but I'm also talking about things that we can determine through questionnaires or by manipulating people's environments, right, and seeing how that impacts their behavior. And then finally is the law of parsimony, and this is the idea that if there are two explanations for a set of events and both are equally plausible, because the university tends to be an orderly place, the simplest explanation is most often the correct one. Okay, so generally speaking, we want to try and keep our explanations of events as simple as possible. It isn't to say that certain behaviors aren't complex, but kind of like with conspiracy theories, right? Conspiracy theories tend to fall apart because they're just too complicated. Whereas a simpler explanation for certain events is going to be much more likely to be true. Okay. Some of the assumptions of the scientific method. So I've mentioned this idea of theories and hypotheses, right? Theory is an explanation for a set of events. Hypotheses are some kind of prediction. The assumptions are first that theories and hypotheses must be testable, all right? And what that means is that if we ask a question, it is something that can be tested through observation. So I cannot test a hypothesis about whether or not people live past lives because there's no way to directly observe that. However, I can test a hypothesis about the extent to which people who believe they have lived past lives have make different kinds of memory errors than people who do not believe they have lived past lives, right? So I can answer some questions about that issue, but the way in which I ask the question will dictate whether or not it is actually testable. Falsifiability is a really critical assumption of scientific research. In other words, we need to be able to design our studies in such a way as to be able to prove ourselves false or wrong. And that is a critical component. If we only design our studies in a way as to ensure that our hypothesis is correct, then we will fail to notice if there is evidence that is counter to our theory. But if we set up our study in such a way as to be able to be proven false, then it makes our study that much stronger. And we'll talk more about this idea of falsifiability later. And then repeatability, meaning that given the same set of circumstances across different situations, we should still get the same outcome every time, right? So our findings from a research study should be repeatable over time, given the same exact set of circumstances. And if it isn't repeatable, if it's not reliable, then it isn't the truth, right? That if we ever falsify a conclusion that we've drawn through the scientific measure, we then assume that that conclusion was always wrong. And then tentativeness, and this is a really critical piece. We can never prove our hypothesis is true. And we'll talk more about this when we get into hypothesis testing logic later in the semester. The only thing, the most we can say is that we have evidence to support our hypothesis, but we never say that we have proven it to be true. However, we can in fact prove our hypothesis to be false or to be wrong. And that's because, as I mentioned, if at any point in time we falsify a hypothesis, that suggests that what we found was never truth, that it was always wrong, okay? And again, this will all be made much clearer to you as we get further in the semester, but I wanted to just kind of introduce you to some of these ideas now. Okay, so what are the steps of the scientific method? The first is to choose a research question. So how do we do this? Well, we choose questions by observing the world and asking questions about what happened, how it happened, why it happened, and that tends to be the beginning. So for example, my research on problematic cell phone use really came out of observing my kids using their cell phones and college students using their cell phones and wondering what is it that is contributing to certain people using their phones at problematic and dangerous times, whereas other people don't seem to have problematic levels of use. And through our lectures and discussions, we're going to talk about how we can tell if a research question is really a good one, whether it's worthy of exploration. Actually, two of those things is one is that it adds new knowledge, and two is that it can be tested empirically. And we'll talk more about that later. The second step is to conduct a literature review. And that essentially means looking at what has already been done to answer this question. So when I started thinking about cell phone use, problematic cell phone use, the first thing I did was I went into a library database and I looked up to see what had other people done to understand the predictors of problematic cell phone use. And the reason this is important is because we don't want to do the same things over and over again. While repeatability is important, research should also lead to advances in knowledge. It shouldn't just replicate what's been done before, but it should result in advances in knowledge. And so I need to know what's been done already in order to know what still needs to be done. Other things that we'll talk about this semester are where do we find literature? How do we do that? What's the procedure? And then what counts as a good source versus a bad source? The third step is to develop a hypothesis, right? And we talked about this as being kind of an explanation or prediction about certain events. Oftentimes we will make statements about the direction of the effects. So I might say something like people who are high on this personality trait of sensation seeking are more likely to be heavy drinkers. That would be a hypothesis, right? So I'm making a prediction that having a particular trait will predict high levels of drinking. And I even am suggesting the direction of that effect. So that's what a hypothesis is. We'll talk more in our lectures coming up about how we turn a research question into a hypothesis, as well as what the characteristics of a good hypothesis are. I've combined steps 4 and 5, which are design and conduct a study. And in this class, we're going to talk about what the characteristics of a strong study are, right? So we want to make sure that when we design our studies that we have the greatest confidence that what we have found is true, but also allows for the possibility that we are wrong, right? So our studies need to include the possibility of falsifiability. And we also need to kind of ask the question about who should we include in our study, right? So what's our population and who are we really interested in knowing things about? Because the purpose of research really is about making predictions about what's happening in the real world, but we can't study everybody who has a particular problem, so we're going to have to select some small subset of people and use that small subset to make conclusions about a larger group. We'll talk more about that when we talk about sampling. Step 6 is analyzing the data, so this is where we get into statistics, and you will learn some of the statistical tests that researchers use to test their hypotheses, as well as you will be able to eventually determine what the correct statistical tests are given a specific research question. And then finally, we want to report our results. And the idea here is that research is only meaningful if it contributes to generalizable knowledge about a problem, right? So if I study problematic cell phone use, but I don't share anything I found, then what is the actual benefit of that research? It's non-existent. My understanding, it is not a benefit. I need to share that information so that other scientists can read it, so we can begin to understand the problem more fully and eventually perhaps come up with some way of intervening and preventing this problematic behavior. Okay, so in the next slide, or in the next lecture, what I'm going to do is walk you through an example of some research that I have done since I've been here at Towson. So I'm going to end here and continue on the next video.